Hello, thank you for your interest in our Material Science and Engineering PhD program. I am very excited today to talk to you a little bit about our research group. We are located at this beautiful uh, Salt Lake City metro area. The picture you see in this front cover, this is Snowbird Ski Resort in the summertime, and this is only 25 minutes away from our campus. I can only assure you about that this is a wonderful place to study, stay, and play. So a little bit about what we do as a research group. So a little bit about my previous background and my research experience. Before I came here as an assistant professor last year, I did my PhD in chemical engineering at the University of Colorado Boulder. Um, Went to the 3D printing of polymer materials industry for a couple of years. It's a startup company at Boston, Massachusetts. Um, and then I came back to the research world, did a postdoc training at the National Renewable Energy Laboratory, which is also located in Colorado. So right now we are a really young research group. We're rather small, but we are a very vibrant group, and we have been having a lot of fun. A little bit about our capabilities, right? We do experimental polymer chemistry and polymer materials development. So we have typical wet lab chemistry capabilities from synthesis to running photochemistry, particularly photopolymerization. We are a experimental polymer chemistry group. We use a lot of chemicals. We have a lot of materials in our group. We also do polymer processing, right? So, for example, we have a speed mixer that's particularly useful for very viscous liquids, and we have um, equipments for carbon fiber composites processing, such as filament winding capabilities. Of course, we also have resin 3D printers to test our own 3D printable materials. In terms of characterization, we have a classic suites of material characterization, such as dynamic mechanical analysis, rheology, gel permeation chromatography. This is to measure the molar mass of polymers, as well as real-time Fourier transfer infrared spectroscopy, particularly with a real-time UV radiation setup. This is to monitor the reaction progress for UV-induced polymerization reactions. Being in a really big flagship state university, we are really lucky to be able to use all kinds of state-of-the-art facilities. Basically, anything that they can think about and everything that we can think about, we have it here in our school. It's a really great place to do research. A little bit more about what we do, right? I know polymer is a really big field. We are particularly interested in thermal sets or cross-linked polymers or networks, right? So these have um, cross-linked architecture on their covalent bonding, forming a really tight network. Why we care about it? These are wonderful materials. They have very good strength and they have very high long-term stability and performance. And we really like the fact that they can be cured from liquids, right? So for example, this two parts epoxy, right? When you mix them together, it hardens into a really good materials. And there is no solvent involved, right? From a stability standpoint, it is really advantageous because there's no volatile solvents involved. In terms of what we do, we work a little bit on chemistry, even though chemistry is not our main focus. We work on new processing, for example, what I showed, filament winding and 3D printing. Our bread and butter is obviously polymer design, right? We really focus on the structure property relationship in polymer materials. And in some cases, we develop new measurements as well. Um, so in this video, we have a polymer sample, right? That's that's holding a hammer, meaning that it is a really heavy object for this piece of plastic. It's really rigid, right? So it holds the hammer pretty well. But as soon as we apply heat,
Oh.
and this, I don't know if you can hear the satisfying aha from my graduate student. As soon as we apply heat, this polymer goes back to its original form. And by doing so, it actually lifting the hammer up, meaning that it actually um, pulling the material, pulling the weight up like a rubber band. But it actually actuates a lot more force than a typical rubber band, right? Because it's a glassy polymer rather than the soft rubber. So we have been calling this new class of material glassy elastomers, and we are really excited about that. Okay. Oops. The whole point of today is, we really want you. We are a really fun, really vibrant group. Um, and it's really I mean, seeing all the students interacting with each other is really a lot of fun for me. And I send students to conferences, right? In the picture on the right, you see PhD students presenting in a conference recently. Feel free to email me for any questions you might have, and I really look forward to interact with all of you.